Assalamualaikum everyone. Let's learn about light reflection at a spherical mirror. What is a mirror? It is typically made up of glass with a flat or curvy surface, and it has a reflective thin coat of metal covering over it. So before mirrors were manufactured, a pool of water were often used to see a reflection. But nowadays, we can have a mirror made up of different kind of materials for different purpose. In our previous subtopic, we have learned about flat or plane mirrors. Now let's learn about spherical mirrors. Spherical mirror are also known as curved mirror. A spherical mirror is made up of a section of the sphere which has a radius r and also a center C right here. We are going to learn two types of spherical mirrors. The first one is concave mirror and second one is convex mirror. The easiest example that I can get around me is this aluminium spoon. It has two surfaces which I can use as a mirror. The first one is concave surface. The second one is the convex surface. So let's see another example of concave and convex mirror. First, a concave mirror is being used by doctor or dentist to examine teeth, ear, nose and throat. It also can be used as magnifying, shaving or makeup mirror, light reflectors or torchlight or vehicles, and also solar panels to collect solar energy. The example of convex mirror, rear views for vehicles, traffic safety mirror, and also shop security mirror. Concave mirror, also known as converging mirror. In bahasa Melayu, we call as cermin menumpu. You can refer to this ray diagram for concave mirror when the incident light rays reflected from this mirror, it will converge at a point. Sinar cahaya yang dipantulkan oleh cermin ini akan menumpu pada satu point. Second one, we have convex mirror known as diverging mirror. In bahasa Melayu, known as cermin mencapa. Based on this ray diagram for convex mirror, the light rays that being reflected from this mirror will diverge from a point. Sinar cahaya yang dipantulkan oleh cermin ini akan mencapah keluar daripada point tersebut. That's why we call as diverging mirror. Let's learn about the ray diagram for concave and convex mirror. Before that, we need to understand the symbol and terms that being used for both mirrors. From these two diagrams, we can see that the differences between concave and convex mirror are the position of point C, point F. Point C and point F are situated here for concave mirror. But for convex mirror, point C and point F are situated here. What makes the difference? Okay, dia macam ni. Daripada satu sphere, concave mirror adalah sebahagian yang kita ambil daripada permukaan di sini. Okay, sekiranya cahaya datang daripada sini, so concave mirror adalah permukaan yang di sini. Dan center dia berada dekat sini. So kita ambil permukaan ini sebagai concave mirror. Tetapi untuk convex mirror, kita ambil permukaan yang di sini. Jadi dia punya center berada dekat sini. Here. Okay, so pastikan anda tahu kat mana position of point C and point F for both mirrors. Apakah nama point C ini? Dia adalah center of curvature. For concave mirror is situated in front of the mirror, while for convex mirror is situated behind or at the back of the mirror. Point F adalah focus point. It's situated between point C and the mirror. Same goes to convex mirror. Focus point situated in between point C and the mirror. P is the pole or vertex, titik tengah di antara cermin. Okay, kalau ini hujung cermin sampai hujung cermin, P dekat tengah-tengah, dan point P, point F, point C is situated on the same axis known as principal axis. This line AB is the aperture line being measured from the end to the end of the mirror. The small letter f is the focal length. It is the measurement of length between point F and the mirror. R is the radius. It is measured from point C to the mirror. R is also equal to 2 times with the focal length. So before we learn how to sketch the ray diagram, please understand the terms and symbol being used. Okay? What is actually a ray diagram? Gambar rajah sinar. It's actually a method to help us determine the position of image form and also their characteristics. For example, I want to sketch a ray diagram for concave mirror. So what I do is, I sketch a concave mirror, and this is the principal axis. I label the position of C and F. Let's say the object is situated here. Apply the law of reflection, where there will be incident ray and reflected ray. At the same time, there's also incident ray directed here with the reflected ray. When there is intersection of reflected ray right here, thus the image will form here. Apabila ada pertindihan di antara sinar pantulan, maka image akan terhasil di situ. So after this, we are going to learn the step by step how to sketch the ray diagram for concave and convex mirror. Let's start with concave mirror. Before we go to step 1, please make sure that you have pencil and ruler. So, sketch the correct concave mirror, the principal axis, the aperture lines, label point C and point F. Please make sure that point F is labeled in the middle between point C and the mirror. And then why do we need this aperture line? It's very important because some of you are going to sketch the concave mirror like this, some of you are going to sketch it like this, so it will have different kind of curve shape. So this aperture line will help you to standardize all the reflected ray later. And then this side we call as the front of the mirror. Why? Because the incident ray will come from here. And then this will be the back of the mirror. For this example, we assume that the object is situated in front of point C at this point. Alright, so what is the step 1? Incident ray from this object will be parallel to the principal axis. So you're going to make a line from the object parallel to the principal axis until it touches this aperture line. After that, the reflected ray will pass through the focus point F. Step 2, we will have incident ray from this object that pass through point F and touch the aperture line. After that, the reflected ray will be parallel to the principal axis. Step 3, incident ray from this object that pass through point C, the reflected ray will also pass through point C along the same path but opposite direction. This ray is optional. Why optional? Because kalau step 1 dengan step 2 tadi dah menghasilkan intersection between the reflected ray, so we will know the position of the image. So step 3 tak buat pun tak apa. Now let's look at the overall steps. If you want to do all the 3 steps, thus we will have step 1, incident ray will parallel to the principal axis and reflected ray will pass through the point F. Second step, incident ray will pass through point F and the reflected ray will parallel to the principal axis. And the third step, incident ray will pass through point C and the reflected ray will also pass through point C but at different direction. From this ray diagram, we can see that there are intersection of reflected ray here, thus the image will form here. What if I just want to do 2 steps? Step 1, the incident ray will parallel to the principal axis and the reflected ray will pass through point F. Second step, the incident ray will pass through point F and the reflected ray will parallel to the principal axis. So by using these two steps only, we will have the intersection between the reflected ray. So the image will form here. So it's up to you whether you want to do 2 steps or 3 steps, but please make sure there is intersection between the reflected ray. From both examples shown here, we will know the image is diminished, inverted, real, and formed between point C and point F. Now let's learn how to sketch the ray diagram for convex mirror. What are the differences between convex and concave mirror? First, the shape or the curve of the mirror is different, and also the position of point F and point C. For convex mirror, point F and point C is situated at the back of the mirror. Now let's assume that the object is situated at this position. Step 1. Incident ray will parallel to the principal axis until it touches the aperture line, and then the reflected ray will diverge from the focus point F. Since this is the diverging mirror ataupun cermin mencapah, that means the reflected ray akan mencapah keluar daripada titik F. This dotted line is virtual ray because it's formed behind the mirror, and this is the reflected ray. Step 2. The incident ray will pass through point F. This dotted line shows this is a virtual ray because it's formed behind the mirror. And the reflected ray will parallel to the principal axis. This ray is optional, so it's up to you. Step 3. Incident ray will pass through point C. This is the virtual ray because it's formed behind the mirror. And the reflected ray will reflect from point C also along the same path but in opposite direction. For the overall steps, you can draw at least 2 or 3 incident ray. So first step is the incident ray will parallel to the principal axis and the reflected ray will diverge from point F. Second step, the incident ray will pass through point F and the reflected ray will parallel along the principal axis. Step 3, the incident ray will pass through point C and the reflected ray will pass through point C along the same path but with opposite direction. So where is the intersection between the reflected ray? We can see that the reflected ray will intersect at this position. Thus the image will form there. What if I want to do 2 incident ray only? So step 1, the incident ray parallel to the principal axis and the reflected ray will diverge from point F. I skip the second step and I terus pergi kepada the third step, which is the incident ray will pass through point C and the reflected ray will pass through the same point but in opposite direction. So kat situ kita akan nampak juga ada intersection point between the reflected ray. Reflected ray yang line warna merah tu, thus the image will form there. If you wonder how to determine the characteristics of the image formed from this ray diagram, so it always start from the principal axis and then you sketch the image formed at the intersection point. So from here, we can see that the image is upright, diminished compared with the size of the object, so it's much more smaller, virtual. Why did I say the image is virtual? Because it formed behind the mirror. Position of the image is between point F and the mirror. This is the reason why we sketch the ray diagram, because we want to determine the characteristics of the image. So from this video, I hope you can understand about the ray diagram for concave and convex mirror. For the example 1.3 and 1.4, I will do a separate video for the explanation how to sketch the ray diagram.